Okay, good everyone. Welcome to my YouTube channel. Now, in today's video, we're looking at atomic structure. Now, when you hear of this name, atomic structure, it means that we're talking about everything containing atom. Yes. Now, first of all, what is an atom? What is an atom? Now, an atom is a divisible particle of an element that can take part in a chemical reaction. Now, there's a man they call John Dalton. John Dalton. Now, this man, in the year 1808, he discovered that atoms are like grains of sand. When I mean grains of sand, it means that atoms are indivisible. He said that in his discovery, in his theory, that an atom is an indivisible particle of an element. Now, that is wrong. I'm going to prove it to you. When they make use of the word indivisible, it means that it cannot be broken down. It's just like your grains of sand. Yes, there is no way it can be broken down into any tiny particles, but it is wrong because atom is divided into three parts. They call these three parts the building blocks of matter. We have the neutron, okay, we have the electrons, and we have proton. Okay, so they call these the three building blocks of matter. Let's go again. Neutron, electron, and proton. Okay, so this neutron means no charge. Electron means there is a negative charge. Sorry, negative charge, and your proton is positive charge. Okay, now this electron, proton, and neutron were discovered by some scientists. And based on their discovery, they proved that what John Dalton's discovery was false. Are you getting me now? I'm going to mention some of their names. Now, some of those scientists, we have the first one, J. J. Thomson. Now, this JJ means Joseph John. It's a short word or a coded way or abbreviated. So the second one, we have Eugene Gould. Eugene Gould. We have the third one, Ernest Rutherford. Ernest Rutherford. And we have the last one, James Chadwick. James Chadwick. Now, you see these four scientists, they made their own discovery based on atom. And based on their discovery, we came to understand that John Dalton's discovery was what? False. Okay, now for J. J. Thomson. J. J. Thomson discovered the electrons. So the electrons which are negatively charged that exist at the outer shell of an atom. When I mean outer shell, when you draw your shell, this is your small nucleus. They call this one inner electron. Yes, so this is your outer shell. So that electron that revolves around it, like example 2, 4, 6, 8. So they call these ones electrons. So it was discovered by a man called J. J. Thomson. Now, the Eugene Gould, which is the next person, discovered proton, which is positively charged. Now we have Ernest Rutherford. Ernest Rutherford discovered neutron, meaning no charge. And the last one is James Chadwick. James Chadwick discovered the nucleus of an atom, which is this small thing you are seeing here. The nucleus of an atom. So these are the scientists, and like I said, based on their discovery, we came to understand that John Dalton's discovery was false. Okay, now the next one is energy levels and number of electrons. Okay, now so we have up to four energy levels. We have them as K, L, M, N. So in some places you can see it written as six, the O and the P. Now majorly we are focused on these four, not the O and the P. They are not majorly necessary, but in case if you see them, you can see make use of them. So K, L, M, N. Now what I'm going to do now is to number them. K will take the number 1, L will take number 2, 3, and 4. Now these are the four energy levels we make use of majorly in chemistry under atomic structure. So energy levels. So we've identified them. And now numbers of electrons. Now the formula we use in order to get the number of electrons is n equals to 2n square. So this is the formula. So this your n represents the number here. So now we have k equals to 2 open bracket 1 square. 1 square is what? 1. So 2 times 1 is what? 2. So it means that the number of electrons that can occupy this K shell is 2. Let's do it for L. So we have L. L is what? 2. So we have 2 open bracket. This is the initial formula to get the maximum number of electron in an energy level. If they ask you the formula used to get the maximum number of electron, if they give an energy level, then you make use of this. Okay, and also I didn't put this. This is energy levels. They call this one sub energy levels. Before I forget, SPDF. These are energy levels, sub energy levels. Okay, so let's continue. So our L is what? 2. So I just put this in here. Equals to 2 square is what? 4, right? So 4 times 2 is what? 8. The next one for M, we have 2 open brackets 3 square. That is 18. We have n equals to 2 open brackets 4 square. 4 square is what? 16. So 16 times 2 give you what? 32. So it means that these numbers you are seeing here is the maximum number of electrons that can occupy each energy levels. Anything more than that is out of it. Are you getting me now? So now the next thing we're looking at is the shape of orbitals, which you can see over here. Now, like I said, this one they call them energy levels, and they also call these ones orbitals. Yes, orbitals. S, P, D, F. Okay, now so for the S, the shape is spherical, it's just like your orange or a circle of ball or whatever thing that is in that circular part. Spherical. You have P is called a dumb bell. So this is it. This is how it looks like. So you have the next one D. D is called double dumb bell. Okay, so you have the next one F. F is called the complex. So it's a mixture of multiple lobes and so on. Okay, now when it comes to filling of electrons in an orbital, now there are some specific rules we follow, and one of that rule is what? Aufbau principle. Okay, we have up to 3 rules or principle we follow when we are filling electrons. These are the electrons like this in an orbital. So like I said, the first one is what? Aufbau principle. Now it states that the filling of electrons should start from the lowest energy level. Like I said, we have 4 energy levels. You can take them as KLMN or this. They are still referred to as what? Energy levels. So the filling of electrons in an energy level should start from the lowest down to the what? The highest. So now let's say this is the lowest, 2. It is the lowest. And this is the what? The highest. So Aufbau suggested that if you are to fill electrons in an orbital, let us start from the energy level that has the lowest electron down to the energy level that has the what? Highest electron. Are you with me now? So you can see it here: 1s, 2s, 2p, 3s, okay, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, and so on. So that is based on Aufbau principle. So now the second one is the Hunt rule. So now this rule states that the filling of electrons in an orbital should not be more than 2. Okay, and each must point in an opposite direction. Now, if you look at this one very well, this one has like 6, a big box, and you have 2 inside of it. So you have, if you look at this first one now, you can see it now. This is the box. Okay, so the electron in this box now is 2, and they are pointing in an opposite direction. They're like 7. So up, down, and this way. So the way this one is not the way this one is. So this one is like upside down. So this one is what? S. The other one, the same thing. But now this one is long. Even though it is long, it is divided into three. One, two, one, two, three. And you still have the same thing. Are you following now? Okay, now so that is it. 1s, 2s, 2p, and so on. So now we have the next one, Pauli exclusion principle. Now this principle states that no two electron has the same four quantum numbers. Now we have examples of quantum numbers. We have principal quantum number, we have magnetic quantum number, we have azimuthal, and we also have what? Spin.